Okay, hi guys. Heading into kind of the meat here of the sciences. In TOK we break up the course into kind of these areas of knowledge that we study, right? And so we look at the sciences, the natural sciences, and the human sciences, and then we look at mathematics, religious knowledge systems, these ideas, and then inside of each one of those we're trying to look at these four domains, right, we're trying to come up with these four things that we can really understand about them, specifically. So like, what is the scope of that area of like knowledge? What is the process of that area of knowledge? How they generate claims, and then like how we relate to them, right? And then how we have individual perspectives on that area of knowledge, and then how ethics operates in that area of knowledge. And that's why we started with ethics first. We started with ethics first because the ethics conversation continues on as we look at all these other areas of knowledge. So today we're going to, so before we can really dig into the more interesting and fun stuff of science, like what kind of questions can science even answer, is it possible to know everything with science, or are there some things that not even science can know about, or just inappropriate ideas for science to like pursue, and the ethics of science? We have to have a better understanding of what science is and how science operates, what the process is, and what the scope of science are. Right. So we're going to hit those first two domains, the scope and the processes, and then that gives us space to kind of hop into the other things, especially because I was reading some of your discussion posts about what your relationships were to science, and it seems like there's kind of a wide variety. Some of you are very into the sciences and are already really engaged and like interested by like scientific ideas, and some of you seem to not be very comfortable talking about the sciences. You seem to like them well enough, but it's not something that you're super comfortable or like confident with. So today we're going to talk about science and what science is, right? So what is science? So first, one of the most interesting ways to think about science is just it is seeking simplicity. All right, it is a reductionist practice where we are trying to understand things in the most basic ways that it is to understand this. So for instance, if science wants to know what a person is, right? If you wanted to know me, a lot of you would start with my personality and my interest and my hopes and my dreams and the things that I want to do, and my family and my children and all that. And those things are all important, but that isn't how science would approach what I am. Science is going to want to decompile me into my component essence. It wants to know, what is the material makeup of me? What am I at an atomic level? And then build up from there. It wants to reduce me to my simplest components first, right? So when we look at our universe, when we look at our lives, when we look at ourselves, we see these things of immense complexity, which is like absolutely true, right? Science is trying to find a way to simplify those complex systems to the furthest degree, so that way it can find understanding, because understanding and truth is going to lie in the most simple level of things. All right, so science is also more than anything, it's a way of thinking. It is a process of thought, right? And so in this pursuit of this simplification and the emergent truth that comes from that simplification, right? You Science uses a very specific, particular way of thinking and investigation to arrive at those conclusions and at those truths and at that simplification. Uh, and so, whenever we think about science in school, we think about all these things that we have to memorize, and the parts of the cell, and the laws of physics, and all the math that's involved. And all that is a part of the science content knowledge, but that isn't what science is. Science is a process of knowing, it is a way of thinking about things. That is what science is. And then we apply that process, we apply that way of thinking to all these different areas, and then we generate content knowledge in all those different places through the way that we think about them, right? It's not inverted. It starts with the process and with the thinking, and that is what generates all this other stuff. Um, and so that is then what leads it to a very specific form of knowledge, which, because excuse me, because science is a process, in a very specific process, it leads to a very specific form of knowledge. But specifically, that it has to be knowledge based on observation, right? All science has to be testable. It has to be based upon observed realities, right? We don't call things that are not based on observed realities the sciences. We call them the theoretical schools, right? So, and there are theoretical schools of science, right? Like theoretical physicists and stuff. And what they're doing though is still kind of science because, um, like if I wanted to come up with a theory for the multiverse, right? For this idea that there are all these different universes that exist simultaneously, and that in them every variable ever possible exists, right? That's the basic idea of the multiverse. Well, I'm basing that theory on the observed reality that we inhabit now, and what might and in the theory gives context to our observed reality, right? And so it's still based upon the observed reality. It's then just applying unobservable theory to the observed reality. And those are not the same thing as the normal, typical um, scientific process, but it is still kind of following uh, the scientific method. Anyways, all of that to say, the most important thing is that science is a very specific form of knowledge based on observed reality. All right. And what that gives us is that it gives us a long history of knowledge, right? Is that unlike something like religious knowledge systems, which are based on revelation, right? The most base level of all religious systems is a revelation, is a truth revealed to somebody from a higher power, right? And there is no way to chart the origins of that knowledge beyond that revelation to the person, right? Like if God puts knowledge into my brain through a vision or a dream or like whatever, right? You can't see where that knowledge continued to come from. What science gives us is we can look back through our human history and see the evolution of our knowledge. We can see the history of it, and we can see where we got things wrong. One of the things that science is comfortable with is science is perfectly comfortable being wrong whenever it encounters new evidence that contradicts it. And it's perfectly okay with that. And that is and so in that way it allows us to not fool ourselves. It allows us to not be comfortable being wrong, right? Because it is constantly questioning itself and questioning its like history and the knowledge that has come before it. Every time that we get new information, new things that we have observed or tested, right? Then we have to see if that jives with this long history of knowledge. And if not, we do not say that this new observation must be wrong. We say maybe the new observation is wrong, or maybe everything that we thought we knew was wrong. And both of those are equally okay. And so that also then leaves us to the fact that science gives us a way to describe our reality, much the same way that religion gives us a way to describe our reality, because it gives us the context for our like natural existence, right? We exist because God created us and God wants us to, right? Science also gives us a way of describing our reality. It gives us a way of understanding our universe, our place in it. It gives us a cosmological argument. It gives us an origin of the universe. It gives us those things, and so it is a way of describing how we exist. And then it also gives us a history of progress, and that goes back to this history of like knowledge. For humans, our progress has been inextricably tied to knowledge. If you look at human history and if you look at human development coincides with the acquisition of human knowledge, and so to understand one is to kind of understand the other. So, here's a nice quote. All right, science is built of facts as a house is built of stones, but an accumulation of facts is no more a science than a heap of stones is a house. And I think this is really important because what that means is like if I take this and I drop it, right, and I observe it, I've not done science. I've observed a fact, which is that this falls, right? Excellent. But there's no science there. That's just an observation. And I can accumulate a ton of observations, but if I can't give context to them, if I can't ascribe meaning and causation to them, then I've not done science. Science is to find the meaning and the cause behind the things that we observe, all right? Um, so, modern science is really kind of the only sensible way to understand the working of nature. And what I mean by that is that for a long time we tried to understand nature through a wide variety of ways, right? If we saw lightning and thunder, it was because Zeus was pissed, right? If an earthquake happened, it was because Hades was rolling around in the underworld and wasn't really happy about things, right? Um, if if there was a tsunami, it was because one of the Shinto gods was angry because there wasn't a sacrifice, right? And so we used a lot of religion to explain the like natural world until we came up with the scientific method, which then allowed us to kind of do these testable observations. And as we did that, we realized that science gave us a very sensible and a very pragmatic way of understanding the natural world around us. And we started to understand things like no, thunder and lightning are aspects of weather systems and like atmospheric pressure, that earthquakes are the shifting of tectonic plates, and that the earth and that the surface of the earth is actually moving. And hey, also at one point in time, that surface of the earth was all combined together in one giant piece of land called the Pangea. Until like continental drift happened, and hey, that happened because the Earth was actually originally a giant ball of molten iron and a bunch of other stuff, and hey, that thing in the sky that's the moon was actually probably a piece of Earth that got knocked off at one point in time, and maybe that's why the Earth is spinning as well. Like, like science gives us a sensible way to understand our natural existence, which is really important because at the end of the day, also we are animals and we are a function of nature ourselves. And so that being science then also gives us a sensible way to understand ourselves. In many ways, evolution has given us a very sensible understanding of a lot of human behavior and human practice and like human history. It helps us understand the differences in things like skin tone and melanin levels. It helps us understand things like human psychology and patterns of behavior. And 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 so we get this sense of self also from science. So an example, right? So, climate change, right, is probably one of the biggest critical global issues of our time, right? If you look at what the readings are showing, and if you look at kind of the way that things are trending, it looks like we are in some pretty bad negative feedback loops, and things are just like getting worse and worse and worse, and it's pretty bad, right? And so recent events have empirically demonstrated that we have a growing vulnerability to climate change. That climate change definitely seems to be happening, and something like over 60% of the human race lives within just a couple miles of the shoreline of an ocean, and that seems to be pretty bad. And so climate change is going to impact agriculture. It's going to endanger food security. The sea level rise is going to like erode coastal places. It's going to cause huge human migration. It's going to increase natural disasters because as the oceans heat up, it's going to make weather more intense. Species extinction is going to be a thing. It's just going to cause all this kind of things, right? Science told us that this was happening 30 odd years ago, right? ExxonMobil knew about it 30 odd years ago. Science was ahead on this. Human and our behavior and our propensity to not want to risk things, right, has kept us going on this path until now we are at a critical mass. Science is what lets us know what is happening, but then also allows us to make projections about what will happen. Because we have this observational data, right, that starts back here, and it gives us this long history of the way that the things in the world were and the recordings that like we had in the past, and then we can compare our like modern recordings to those, and we can compare levels of carbon dioxide in the atmosphere and the levels of sea ice and things like that. Then we can start to make projections about how fast this is happening and then what it's going to look like in the future. And this is all because of that scientific way of thinking. Because remember, science is not about the content knowledge, it's about the thought process that gets you there. It's about the application of observation in meaningful ways to come to conclusions that are then testable. All right? So, with our example, right? So what are the predictions given, right? Well, the predictions are given about what is going to happen, right? Based on what we know now, right? And so the evidence, right, is what we have observed compared to the historic data, right? And then that is what allows us to make these predictions of the future, right? So yeah, and that is how science works. All right, so what all that means is basically science is an organized, systematic process that gathers knowledge about the world and condenses the knowledge into testable laws. And the testability there is really, really important. Every scientific claim has to be falsifiable, meaning that it has to be something that you could test and then prove whether it is true or not. If it is not something that is testable, then we do not consider it to be scientific knowledge. So things like the multiverse are not scientific knowledge. They're a scientific theory. They are a theory based on scientific knowledge, but they are not knowledge themselves. Things like God cannot be scientific. Things like oh man, what else is not? Well, anyways, we'll get into those into other areas of what is or is not science later. I don't want to get ahead of myself. I also don't want to make this longer than it needs to be. But it is important that scientific claims have to be testable. All right. So basically, this is how science operates. Why? Right. So it starts with the why, which is the inquiry, the like curiosity. So you observe something and you want to know why what you observed happens. Right? So maybe I go into my classroom, and this actually happens on a regular basis. I go into my classroom, and one of my students says, "It's cold in here," and another student says, "I think it feels great." I want to know why. Well, if the temperature is constant, why does one student think it's cold and one not? Right? And you may think, well, that doesn't seem like science. That's not about nature or the world, but it is a process of thinking, and it is testable, right? And as long as I can test it, then it's fine. So I then observe, and basically my like observation here is I'm just going to ask a ton of students, is it hot or is it cold, right? And then I might change the variables, right? Or I might come up with an experiment. Does the color of the room change students' perception to its hot or like coldness? If it is a hot day outside or a cold day, does that change how like students perceive it? So now I'm going to implement variables and then experiment with those variables to see if I can make any claims about why students think that a room is hot or cold. And by testing those variables, I am then making this a scientific knowledge claim. All right. So, are they sciences? Acupuncture. It's a belief that inserting needles into certain points of the body, certain diseases can be controlled. All right. This is the idea of acupuncture. Astrology. The belief that the movement of the stars can influence the human life. Creationism. A belief that every creature is uniquely created by God. Christology, a belief that every crystal has magical powers and energy. All right. Feng Shui, a belief that positioning And physical characteristics of a house can affect the harmony of a house. And then graphology, a belief that handwriting can determine a person's character. So, which of these is science? Are they sciences? So, the number one question here is, which of these is testable? All right? It's really simple, right? So, which of these is testable? Can you test acupuncture? Right? Can you have people undergo acupuncture and then test the results, right? And if the result is positive, right, then acupuncture can be science, because it all depends on the system by which they are pursuing it. Where this becomes more difficult is you get into creationism and astrology and Christology, things like that. There's no way to test those, right? You can probably test graphology, right? But then you get into this problem, right? Can determine a person's character. Well, what do you mean by determine and then a character, right? And so these all become relatively problematic from a testable and falsification standpoint, right? So, how many of these beliefs are true? Let's talk through them. Normally, we would do this as a class, but we can't. So, what separates a science from a pseudoscience? So, basically, science has to be scientifically proven, right? The hypotheses have to be testable. There's clarity and simplicity in the results, and rarely any exceptions. All right? These are the ways, and the rarely any exceptions is because, especially whenever you get into the human sciences, you're looking at patterns of things like behavior, and so you're going to be looking at what's called the normal distribution, and we'll get into that later. But it's still testable, and it still gives you a clear indication of a probability of something, right? And so remember, in life, when we start becoming real thinkers, when we start really examining our understanding of existence, what that also means is we start to become comfortable with uncertainty and just thinking about the probability of things, right? And so science hardly ever states certainty. It states probability. It states feasibility, all right? Pseudosciences are not proven, all right? There is the ad hominem fallacy, where they resort to a lot of personal experience and personal attacks. There's also a post hoc priori fallacy that pseudosciences rely on a lot, which is that they look at end results and then say, oh, well, that happened because we did this before over here, right? And so they are making a claim of causation after the fact instead of doing something and say, since we did this, this should then happen, right? Their hypotheses are not testable. There's a lot of vagueness to things like human character, energy, really just, and then there are all kinds of ad hoc exceptions to things that they come up with. All right, so you may go abroad next year. Is this a scientifically testable claim? Think about it. No, because it can't be based on observation, because it's going to happen in the future. You can make a probabilistic statement on it based on the reality of your reality of right now. You could say that if I've got $15,000 in savings and I have plans to go on a trip, then it is probable that I am going to go abroad next year. But it is not it's not really testable, because there's no way of testing it until the event happens. All right. It's always hot on Fridays. Testable claim. Yes or no? Think about it. Maybe, but it's problematic, and so therefore it's going to be hard. So first, we're dealing with this always word. Always is hard. Always is very, very hard in just about everything. And then you got this word hot. And hot is subjective. Hot is not an objective statement. So, hot for what? Hot for December? Hot for December is very different than hot for August. And as I used in my example earlier, hot for me may be different for hot for you. So, how do you define hot? Now, you could say something like Fridays are the warmest day of the week. Well, now that's a testable hypothesis, right? Now we can set up a series of tests to look and see if Fridays are in fact a hotter day, or if they're hotter on average, or I mean, you can do all kinds of things, right? But this, as it's written here, is all kinds of problematic. Rebirth is a fact. I'm not even going to give you time to think about this one. No, because there's no way to ever test it. There's no way to ever test whether or not people are reincarnated. Negative and positive poles attract each other. Talking about magnets here. So this one, yes, obviously, very easy, right? You get a magnet, you get another magnet, and you just see what happens with them. And then you just do that with a bunch of different magnets. And if the opposite poles always attract to each other, then you've made a scientific observation, right? Next one might be surprising for you. Everyone is basically happy. Now, remember, we just want to know if these are scientifically testable claims. Everyone is basically happy. So, surprisingly, this one is indeed scientifically testable. What you would have to do, and we actually do this, there is actually an International Happiness Index where they have come up with a way to quantify how happy people are or are not. And then they come up with averages for countries and towns to figure out the relative happiness of places on like Earth. It involves what are called qualitative studies, which is where you ask people a series of questions and you ask them to rate things on a scale. And you've probably done a lot of these. They are those tests that say strongly agree, neutral, disagree, strongly disagree, right? And those 5 option tests are called a Likert scale. And then you do what is called coding, where you basically assign a number value to each one of those answers, and then you gather a bunch of data from a bunch of people, and you look at what the numbers are, and you look at averages, and you try and figure out people's feelings based on those things. All right, and then last one, acid turns litmus paper red. Obviously, this one is very easily testable. You just need some litmus paper and some acid, and you would just do it a bunch of times to see if it worked. All right? And then something interesting will happen in your life next year. Now, what's problematic with this one? Well, something interesting is very subjective. What's interesting? What I think is interesting might not be what you think is interesting. You would need something testable, right? Something that is more concrete than something interesting, right? So, moving on. The main factors that distinguish science from pseudoscience: experimentation, induction, all right, the hypothesis, laws, measurement, observation, and repeatability, and then an established theory. So, what does this mean? So, basically, a pseudoscience makes claims. They make claims, and then they practice, and then they post hoc apply the outcomes to the claims, right? As where the scientific approach is all about having an observation and a hypothesis, and doing experiments, making observations, making measurements, and then coming to conclusions based on the repetitions of those, right? And the idea here is really simple. When you do science effectively, in an unbiased way, you let the data say what the data says. And you're okay with whatever the data proves to be true, okay? when you get into the pseudosciences, they are only looking for the things that support the claims that they are already making. All right. Science, again, is always okay being wrong. And the way that we establish whether or not it is right is like, is if a scientist over there, let's go back to my room experiment, right? Let's say that I do all this stuff and I did an experiment where I kept the room the same temperature and I had two classrooms, right? And I asked students if the rooms were hot or cold in those two rooms, and one of the rooms was red and one of the rooms was blue. And I found out that even at the same temperature, students felt like the blue room was more cold, right? Well, that's an interesting discovery, right? So now what happens is another scientist over here might do the same experiment, and they might even add a third color room in there, right? And they're going to repeat the same experiment to see if their results match my results. And if their results match, well, then we can start to make some claims. We can start to have a theory here, right? And our working theory is that maybe color impacts how we feel about the climate of a space, right? And that is our theory that we then have, right? And then other people can then test it. And if it proves true enough, and if it proves repeatable enough, maybe someday it becomes scientific law. And that's how we get there. All right. How long have I gone here? I feel like I've been talking for a long time. I have been. So that's all I'm going to do with this for right now. I feel like that was a lot. Thank you for hanging in there. If you've not done your introductory science thingamajigger in Schoology this week, please go do it, because it's going to be important for what we do next week, because next week we're going to start doing some sciences. We're going to start applying sciences and actually being scientists and talking about what makes the sciences hard to practice. And then we're going to dive into like the limitations of science and how we as individuals interact with science and how science helps us understand ourselves. So that's all I got for today. That's all I got for this week, guys. Enjoy the long weekend. You got a couple of long weekends coming up, right? So like you got this weekend. There's no school on Friday. Next week we got a full week, but then you guys are out on the 3rd. Lots of time off. Lots of time off. So enjoy that. Use the time well. Please make sure to find a balance in your life. Please encourage your classmates to be turning in their work. Support each other. Yeah. And as always, if you need anything, please let me know. Always happy to help. Always happy to go out of my way to support you guys in whatever it is that you need. You just have to let me know. All right?